My name is Arthur Bonneau. I'm a prototyping engineer for Amazon Web Services based in Melbourne. And I am excited to have you joining us for the summit online this year. My role in the prototyping team is to help our customers contextualize complex uses of the AWS platform by building working prototypes of specific use cases in the environment. In a nutshell, we help bring to life your awesome business ideas. Amazon is known for its customer obsession, and the AWS prototyping team is no different. Every prototyping engagement starts with the customer. We work backward from the customer business objectives, and then we build a prototype that will serve those objectives. To show you what it looks like in practice, in this presentation, I will talk about a prototyping engagement we've done with a customer that was looking to build an industrial control platform for the growing of algae at scale. In particular, I will explain how we came up with a strategy for the provisioning of hardware devices with AWS IoT Core. This is something that is at the core of any AWS IoT project. So even though I'll be talking about device provisioning in the context of our customer use case, it should really be applicable to any IoT project. Finally, I will show you what this device provisioning strategy looks like in practice by demoing how you can automate the provisioning of a Raspberry Pi using a feature called fleet provisioning that was released early last year. Are you ready? Algae are amazing. They're tiny microorganisms that turn sunlight into chemical energy. There are around 300,000 algae species known to science, and some of them naturally contain high level of oils, carbohydrates, sugars, and proteins, which can be used to make a wide variety of products. For example, it can be used as food for humans. In fact, you've probably eaten food with seaweed in it and not noticed it, as chemicals from seaweed are used in many sweets, desserts, and even drinks. Algae can also be used to create pharmaceutical compounds or grown as feed for animals, and many more use cases. Now, add to all those potential applications the fact that algae grow fast, can be grown in salt water, and are an important carbon sink and oxygen producer, and you'll understand why a lot of people consider algae to be a super crop of the future. At this point, you're probably wondering, if algae are so great, why don't we see them everywhere? Well, the reason is that algae have typically been difficult to grow in commercial quantities. And here's why. To produce high-value compounds using algae, you need to use bioreactors. Bioreactors are containers filled with water and nutrients where you put wild algae, which have little to no value, and put them through a multi-stage process whereby tweaking inputs, such as lighting condition, CO2 level, and temperature of the water, you're able to increase the cell density and then create different compounds expressed in algae, such as beverage ingredients or pharmaceutical compounds. Now, the hard part is that, on the one hand, you need to get the growing conditions just right in the bioreactors to produce usable compounds. But on the other hand, those growing conditions will need to be very different depending on which species of algae you're working with and which compound you want to produce. So you want a process that's flexible enough to be able to produce different compounds using different species of algae, but this process should also do that with a high level of precision. And that's exactly the problem that an Australian biotech startup called Provectus Algae is looking to solve. They have developed a technology that allows them to optimize the production of algae to produce different types of high-value compounds. And they're now looking at applying this technology at a large scale. Over the next 5 years, they intend to build algae production sites, also called biomanufacturing sites, around the world. Each of those biomanufacturing sites will consist of thousands of bioreactors that need to be remotely managed. Also, the production conditions of the algae must be recorded in order to be certified as safe for medical or food uses. To support that long-term vision, they want to build an industrial IoT management platform that will manage every aspect of the lab applications. And as you may have guessed, given the context of this presentation, they decided to use AWS and the AWS IoT services to build this platform. The reason they chose to build this biomanufacturing platform on top of AWS IoT is because it takes care of the undifferentiated development work and operational burden of managing IoT systems by providing a secure cloud on edge with the most standards and compliance certifications of any cloud provider. A transparent pay-as-you-go pricing with no minimum fees or mandatory service usage. The broadest and deepest functionality with the ability to connect IoT devices with over 130 AWS services. And finally, a proven experience at scale with AWS IoT Core alone handling more than 500 million active unique external endpoints per month. And so the Provectus team used AWS IoT to build a simple proof of concept for an IoT platform that controls a couple of bioreactors. But even though they found it pretty simple to build this proof of concept, they still had questions on how to take it to the next stage, managing not a couple, but thousands of bioreactors across multiple sites. And that's why they engaged with us, the AWS prototyping team, to help them build a prototype for a biomanufacturing platform that can scale to support a large number of bioreactors across multiple sites, and that takes full advantage of everything the AWS platform has to offer. One of the main questions we tried to address with this prototype was how do you connect IoT devices at scale to AWS IoT? It's a common question when you go from a proof of concept to a large-scale deployment, because it's simple to manually connect one or two devices to AWS IoT by using the AWS console, but this solution doesn't scale when talking about thousands of devices across multiple sites. This process of connecting devices to AWS IoT is called device provisioning, and it's an essential component of any IoT project that you need to consider early on in the development process because it will impact manufacturing and deployment costs. AWS IoT provides different options for device provisioning. So by going through the work we did with Provectus, my goal is to give you a mental model that you can use in order to pick the best device provisioning strategy for your next IoT project. So let's start by defining what device provisioning means. Device provisioning is the process of setting up a device so it can connect and communicate securely with AWS IoT Core using TLS-based mutual authentication. Provisioning a device involves writing a X509 certificate and the corresponding private key on the device, as well as creating the following resources: an IoT thing, which is a cloud-based representation of the physical device, an IoT certificate, which represents the X509 certificate on the device, and an IoT policy attached to the IoT certificate that describes the action that the device is authorized to perform. AWS IoT offers a couple of ways to provision the device. The first one, which is usually used during early phases of an IoT project, is called single-thing provisioning, where all the necessary resources to provision a device are created through the AWS console, and the developer manually provisions the certificate and private key from the local machine to the device. This process is fine when used for devices not deployed in the field, but it should never be used in production because of the risk of the developer's local machine being compromised. Other options exist to provision IoT devices securely, such as just-in-time provisioning. With just-in-time provisioning, devices' credentials are injected on devices at manufacturing time, and the cloud resources corresponding to the device are created automatically the first time they connect to AWS IoT Core. Now, injecting unique device credentials at manufacturing time is not always possible. For example, some device manufacturers may have minimum order quantities before they provide customization services. In that case, devices can be provisioned after they are sold and deployed in the field, using a service called fleet provisioning. There are two ways to use fleet provisioning. The first one is by trusted user, which requires the end user to use an app to install certificate on their IoT devices. And the other one is by claim, where devices are manufactured with a shared provisioning claim certificate embedded in them. For the Provectus prototype, single-thing provisioning was not considered because of the security concerns mentioned previously, and also the fact that it is too manual when working with thousands of devices. We also ruled out fleet provisioning by trusted user, since it requires an end user or an installation technician to use a mobile app to configure the device in its deployed location, which would add too much operational overhead to the provisioning process. Now, we still have two options left: just-in-time provisioning and fleet provisioning by claim. And before we decide which one to choose, it's important to have a good understanding of how they work. I find that there's nothing better than a good sequence diagram when trying to explain how those two options work. So let's do that. First, let's take a look at just-in-time provisioning. To use just-in-time provisioning, you must bring your own certificate authority, or CA, and register that CA with AWS IoT. You also need to attach a provisioning template to the CA. A provisioning template is a JSON document that details the instructions that must be carried out when a device is to be provisioned. You then use this CA to sign a device certificate and write the device certificate and corresponding private key on the device. When the device connects to AWS IoT Core for the first time, the device certificate and the signer CA must be sent during the TLS handshake. The TLS handshake will fail at the first connection because the certificate has not been registered into the AWS IoT account yet. But this first connection will kick off the provisioning process. Once AWS IoT Core has checked the signer CA and verified the signature of the device certificate, the cloud resources corresponding to the device will get created according to the provisioning template we previously attached to the CA. The device must then reconnect to AWS IoT after a short period of time, and if the provisioning operation has succeeded, the second connection will be successful. As you can see, assuming you can deliver credentials to your devices before they are sold to end customers, just-in-time provisioning makes it easy to onboard large number of devices with AWS IoT Core. You just need to implement the logic on your devices to send the signer CA on first connection, and also automatically reattempt connection after device provisioning is completed. Next, let's take a look at fleet provisioning by claim. With this method, each device can be loaded with the same shared claim certificate and claim private key. This means the same firmware can be loaded on devices at manufacturing time without the need to perform any customization. The claim private key should be secured at all times, including on the device. We recommend that you use AWS IoT CloudWatch to monitor for indication of misuse, and if you detect misuse, disable the provisioning claim certificate. With fleet provisioning by claim, when a device establishes a connection with AWS IoT for the first time, it connects with the claim certificate and exchanges it for a unique private key and X509 certificate, signed by the AWS Certificate Authority. Once the device has securely stored its unique certificate and private key, it triggers the provisioning process by publishing to a fleet provisioning MQTT topic, passing a provisioning template name as well as the device attributes as parameters. Before the fleet provisioning service starts the provisioning process, it triggers a Lambda function that can be used to perform validation logic, such as checking for the presence of an embedded hardware secret in a request, or checking the device serial against a table with verified devices. Assuming this Lambda function validates the request, the cloud resources corresponding to the device will get created according to the provisioning template passed as a parameter. Once the process is completed, the device can securely connect to AWS IoT using its own unique device certificate. As you can see, compared to just-in-time provisioning, fleet provisioning by claim involves more steps to provision the device on its first boot, but it doesn't involve any customization at manufacturing time, since the same claim certificate can be used on every device. Now that we've seen how both options work, we need to decide which option will work best for our use case. As a device maker, you must consider the following when picking a provisioning strategy. Who will maintain the public key infrastructure for your project? What capabilities should you build into your device? And what capabilities do you, or your contract manufacturer, have to provide customization at manufacturing time? For example, when comparing just-in-time provisioning and fleet provisioning by claim in the context of Prometheus Algae, two elements stood out. The first one is that Provectus Algae wanted to use managed services wherever possible. So in that context, fleet provisioning is the best solution, since it allows you to use AWS IoT Managed CA to sign device certificates, whereas just-in-time provisioning requires you to bring your own CA. The other key element is that Provectus wanted to pick the option that gives them the most flexibility in terms of manufacturing solution. They needed a solution that could support a manufacturing supply chain that is potentially not equipped to customize devices at manufacturing time. In that context, fleet provisioning is ideal, since, as we just saw, it allows to onboard a device without needing to perform any customization at manufacturing time. And this is why, for this prototype, we decided to use fleet provisioning as the device provisioning solution. With fleet provisioning, we could just create a firmware that triggers the device provisioning on first boot using the shared claim certificate, which means the Provectus team could go from manually provisioning every single bioreactor to having bioreactors automatically provisioned and ready to be used on first boot. In the following demo, I will show you how you too can use fleet provisioning by claim to create a custom firmware for your devices so they get provisioned automatically when they connect to AWS IoT for the first time. By the end of this demo, we'll have created a custom Raspberry Pi SD card image that we can use on any Raspberry Pi devices to have them automatically provisioned with AWS IoT Core when they boot for the first time. To demonstrate it, we will flash this custom image on this SD card sitting on my desk. Plug the SD card into this Raspberry Pi, and on the device first boot, we will see it automatically register itself with AWS IoT Core and appear in the list of devices in my AWS console. Currently, we can see that this AWS account does not have any device registered with it, but it does have a few resources already. The first one is a provisioning template called Bioreactor Provisioning Template. It's a simple template that describes how devices should be provisioned. It takes a serial number as a parameter, and the certificate that gets created for the device will have a policy called Bioreactor Think Policy attached to it. This policy is already defined, and if we click on it, we see that it will allow our devices to connect using the device name as a client ID and allow them to publish and subscribe to topics that have a name starting with the device name. There is another policy called Bioreactor Claim Certificate Policy. This is the policy we'll attach to the claim certificate that we'll use to provision our devices. As you can see, the policy only allows to create certificates and provision a device using the provisioning template we've defined earlier. Now, this policy is not attached to any certificate yet. So the first thing we're going to do is create a certificate that we will use as our claim certificate and attach this policy to it. For the purpose of this demo, we'll use the one-click certificate creation. We'll download the certificate private key and certificate file and activate it. Finally, we'll attach the Bioreactor Claim Certificate policy to it. And just like that, we now have a claim certificate that can be used to automatically provision our Raspberry Pi. Now, let's open a terminal to start creating the custom Raspbian image that we will use for our Raspberry Pi. To create the custom Raspbian image, we'll need the files you can see in my terminal. The official Raspberry Pi operating system image, called Raspbian, that we will modify to create our custom Raspbian image. The AWS IoT Fleet Provisioning Client, which is a Python client used to demonstrate fleet provisioning for IoT Core, and that you can download from GitHub. You can also see the IoT certificate private key and certificate file that I just created and downloaded on my machine. And finally, a script that we will use to create the custom Raspbian image. Please note that at the end of this demo, I will share a link you can go to find all the source code used in this presentation. To create our custom Raspberry image, we first need to configure the Fleet Provisioning client. If we look at the client config file, you can see I've already partially configured the client by specifying the provisioning template name as well as the IoT endpoint. To complete the configuration, we need to copy the claim certificate keys where the client expects them to be, in the cert folder and with the name claim.pem.crt and claim.pem.key. Now that the client is configured, we can create the custom Raspberry image using the create custom Raspbian script. But before we run the script, let's take a look at what it does. The script has 3 main steps. It starts by mounting the root disk from the official Raspberry image, so we can modify it. Then it copies the configured Fleet Provisioning client on the mounted image. And finally, it creates a script that will run the Fleet Provisioning client on the device first boot. The script starts by generating a device serial based on the device MAC address. Then the provisioning client is executed, passing the device serial as a parameter. And the following section creates the service that will trigger the script on the device first boot. Now that we've seen what the script does, let's run it. Since I'm using a MacBook and this script uses some Linux tools, I need to run this script in a Docker container. As you can see, a new disk image called AWS custom Raspbian.image was created. This custom disk image can now be used on any Raspberry Pi device. And when a device boots up using this image, it will automatically provision itself with AWS IoT Core. And since we're using Fleet Provisioning by claim and a shared claim certificate, we don't need to create a different image for each device we want to provision, and can just reuse the same image. I'm now going to flash this image on the SD card. I've plugged the SD card in my machine, and will now unmount it. And now, I can flash the image on the SD card. Once this is done, we can take the SD card, plug it into our Raspberry Pi, and power our device. While the device boots up, we'll go on the AWS console to monitor for device creation events. And if everything goes according to plan, we should see an event when our device gets created by the provisioning client on its first boot. That's it. Our device just came online and automatically registered itself with AWS IoT. If I now go to the device menu, I can see the IoT thing corresponding to my device. And if I click on it, I can see that a certificate was automatically created and attached to it. This certificate is assigned the bioreactor thing policy, which allows my device to subscribe to and publish to AWS IoT MQTT topics. And that's all it took to set up Fleet Provisioning for our Raspberry Pis. The beauty of it is that I can now use this same disk image to boot any Raspberry Pi, and those will automatically register themselves with AWS IoT. If you're interested in reproducing this demo, you can find the code that I just used and more by visiting this URL. There, you'll find a project that creates a code pipeline using the Cloud Development Kit to automatically create a custom Raspberry image, similar to the one we just created. I'm super proud of the work we did with Productus on this prototype. Once you have a proof of concept for a product you're trying to launch, prototypes are a great way to fill the gaps before moving to a pilot and eventually production. For Provectus, this was an opportunity to see how they could go from connecting and controlling a couple of devices to connecting and controlling thousands of devices across multiple sites. And once we had figured out the connectivity and control aspect of the prototype, things started to get really interesting because we could start leveraging other AWS services, such as AWS Greengrass, to improve resiliency and make sure production was not impacted by eventual connectivity failures. And we also used analytics and machine learning, leveraging the data generated by the bioreactors to further optimize the growth of algae. So this prototype was a great way for Provectus to envision the art of the possible with the AWS platform. And for me, this was also a great opportunity to learn about the fantastic world of algae and help the Provectus team in their quest to build a platform for the growing of algae that's economically viable. But the prototyping team is always looking for new challenges, and we are keen to learn what you are working on. So if you need help with your next project, reach out to your local AWS team to learn about how the prototyping team can help. You joined the AWS Summit to learn, and you can keep the learning going after the summit with IoT resources from AWS training and certification. We offer over 25 free digital courses on demand, so you can learn wherever and whenever it suits your schedule. For more information, visit our learning library at aws.training and look for IoT domain. I hope this session has been useful, and I really want to thank everyone for jumping in and listening. I also want to thank the team at Provectus Algae for allowing us to talk about the journey with the prototyping team and AWS IoT. Thank you so much. Don't forget to fill the survey at the end of this presentation, and have a great day.